Hi everyone, this is your math guru. In this video, I'm going to show you how to calculate the angle formed between two lines. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. We have calculated the angle theta, which is formed by the two lines in each of the following diagram. Round off your answers to two decimal places. So to start with, what I'm going to do is to highlight the angle formed by the line AB. I'm going to call that my alpha. And then the angle formed by the line CD, I'm going to call that my beta. Therefore, I need to find alpha and beta in order to calculate my theta. So starting with alpha, the gradient of the line MAB equals my change in y over my change in x. To make it easy for me to calculate, I'm going to tag my point. I have my x1, y1, and then x2, y2. So therefore, that's equal to my y2 is 6 minus my y1, -1. I'm going to put that in a bracket as shown, and then divided by my x2, -1, minus my x1 is 5. So that's equal to 6 plus 1 divided by -1, -5 is -6. Therefore, MAB, or the gradient of AB, as shown, equals 7 over -6. So therefore, in order to find alpha, tan of the angle of inclination, so tan of alpha equals to the gradient of AB. So tan of alpha equals, I got it as -7 over 6. So therefore, I'm going to find my reference angle. So reference angle equals, I'm going to move my tan to the right hand side. So I have arctan of 7 over 6. I'm going to ignore my negative sign for now. So in order to get my reference angle, if I punch that in, that's the second function of my tan button on my calculator. I have 49,40 degrees, which is an acute angle. But if you look at what I have in my diagram, that's an obtuse angle. So therefore, in order to get alpha, alpha will be equal to 180 degrees minus the reference angle, which is equal to 180 degrees minus 49,40 degrees. And my answer will be 130,6 degrees. So therefore, alpha in this case is equal to 130,6 degrees. So I'm going to do the same for B, but beta in this case is an acute angle, so I don't need to find reference angle. So going through the process again by finding the gradient of the line CD, I have M of CD equals the change in y divided by the change in x. So going ahead to tag my points like I did in the first step, I have my x1, y1, x2, and y2. Therefore, this is equal to my y2 is 6 minus y1 is 0 divided by x2 is 3 minus x1 is -2. I'm going to put that in a bracket, and that's equal to 6 divided by 3 plus 2. So therefore, the gradient of the line CD is equal to 6 over 5. To find the alpha, or the angle of inclination of the line CD, I have tan of beta equals the gradient of CD. So therefore, tan of beta equals 6 over 5. That's a positive angle, that's acute. So therefore, my beta will be arctan of 6/5. That's the second function button of your tan on your calculator. Therefore, beta will be 50,19 degrees, which is an acute angle. So I have this is 50,19 degrees. Now, in order to find my theta, I know that external angle of a triangle add up to the sum of the two interior angles. So I'm going to be using the triangle highlighted such that I have the angle alpha, which is the external angle, is equal to the sum of the two interior opposite angles, which is equal to my beta plus my theta. And the reason being external angle of a triangle. My alpha in this case, or making theta the subject of formula, so I have theta will be equal to alpha minus beta, which is equal to my alpha 130,6 degrees minus beta 50,19 degrees. Therefore, my theta is equal to 80,41 degrees. Thanks for watching. Bye.